This video is for topic 5.2, Introduction to Rate Laws. The objective for this topic is to represent experimental data with a consistent rate law expression. Experimental methods can be used to determine the rate of the reaction. So we're looking at the change in concentration over the change in time. And so we can collect experimental data to actually measure those parameters. We can then use those pieces of data to create what we call a rate law. And a rate law shows us that the rate of the reaction is proportional to the concentration of each reactant raised to a certain power. Then we use a rate constant, in this case symbolized by K, to turn the rate law into an equation. So the first part of the rate law is just that it's proportional to the concentration of each reactant raised to a power. To turn a proportion into an equation, you need a constant. That constant is temperature dependent, and the units of the constant depend on the order of the reaction, which we're going to talk about here in a minute. But that rate constant is specific to a particular reaction because it's going to depend on the temperature that the reaction took place and then ultimately the order of the reaction. So we can talk about the order of the reaction in two different ways. We can talk about it with respect to a certain reactant, in which case we write it as the power in the rate law. So we would say that with respect to A, so reactant A, the reaction is M order because the M is the power on the A species in the rate law. With respect to B, the reaction is N order. So with respect to reactant B, N is the exponent or the power, therefore that's the order with respect to B. If we want to look at the order of the overall reaction, we're going to add the two powers together. So the overall reaction order would be M plus N. So we're going to talk about how to determine the orders of the reactions in a later topic, but that's how we talk about the order of reaction. It's dependent on the powers for each of the species, and then the overall reaction order is the sum of those powers.
This question is looking at the reaction of A and B to produce C and D. So in this question, we've done 4 experiments, and we have initial concentrations of A, initial concentrations of B, and we have the initial reaction rates. So question A asks us to determine the order of the reaction with respect to reactant A. And so what we're going to look at is we need to find 2 experiments to compare where B is not changing. So that means we can eliminate B. I'm going to look at experiment 2 and experiment 3. So we're going to start by comparing those 2. So experiment 2 compared to experiment 3. And we know that in general, our rate, I'm going to write this up here, our rate is going to be equal to our rate constant times A raised to some power times B raised to some power. So in experiment 2, our rate is 1.08 times 10 to the negative 2. In experiment 3, our rate is 1.07 times 10 to the negative 2. And then we're going to have K. And then in experiment 2, our initial concentration of A is 0.034 raised to X. Our initial concentration of B is 0.137 raised to Y. In experiment 3, we have our constant. Our initial concentration of A is 0.136. And our initial concentration of B is 0.136. So now we're going to look at what cancels out. Our K's cancel out and our B's cancel out. So what we end up with is essentially 1, because our rates stay the same, equals 0.034 raised to X divided by 0.136 raised to the X power, which means X must equal 0. So we would say that it is 0 order with respect to A. Now, part B asks us to determine the order of reaction with respect to reactant B. So if we want to compare 2 different reactions, in this case, we're going to compare experiment 1 and experiment 2, because we can then factor out the concentrations of A. So we're going to do experiment 2 compared to experiment 1. So our rate for experiment 2 is 1.08 times 10 to the negative 2 divided by our rate for experiment 1, which is 6.67 times 10 to the negative 4 equals K times A, which is 0.033. This time we know X is 0, so we can plug that in, times 0.034 raised to Y, divided by K times 0.034 raised to 0 times 0.137 raised to Y. Now, when we calculate this out, this comes for our rates, comes down to 16.2 equals 4.03 raised to the Y, because our K's cancel and our A's cancel out. This means Y equals 2. Therefore, this reaction is 0 order with respect to A and 2nd order with respect to B. So in C, it asks us to write the rate law for the overall reaction. So we would write rate equals K times the concentration of A raised to 0 times the concentration of B squared, which then simplifies to K times the concentration of B squared. Because if something is 0 order, that means it does not determine, the concentration of that reactant does not determine the rate of the reaction. If we wanted to go through and solve C and D, which I'm not going to do at this point, it's a matter of plugging in units to determine what your rate constant would be. So you'd pick an experiment and plug in the concentration, plug in the initial rate to be able to solve for K. And then once you have K, you can do E, where you plug in K, you plug in your initial concentrations of A and B, and you can solve for your initial reaction rate. So the last two parts are just a matter of using your rate law and plugging in the appropriate values to solve for your missing variable.